that's rotating around this fulcrum here in the center. And on this side, I have a 50-pound weight, and on this side, I have a 10-pound weight. But as you can see, the lever is balanced. You think about it, it should fall towards the 50-pound side, but it's not. The reason being because of mechanical advantage. Now, because of mechanical advantage, the length between our fulcrum point and where the 10-pound weight is hung is 5 times the distance from the fulcrum point and where the 50-pound weight is hung. This makes the force of the 10-pound weight 5 times greater than it actually is compared to the 50-pound weight. So on this side, it feels more like 50 pounds, and same on this side. So the forces are equal. But if I bring the 10-pound weight out just a bit further, we'll start to see the lever go down towards the 10-pound side. Now, our 10-pound side is more than 5 times greater than our distance between our fulcrum and our 50-pound weight. This means that our 10-pound weight is exerting more than 50 pounds of force at the center on this side. So that means that that'll lift our 50-pound weight. But if I bring the 10-pound weight closer to the middle, we can now see the 50-pound weight will pull up the 10-pound weight. What this now means is that our 50-pound weight is more pulling down force than our 10-pound weight. This is because our 10-pound weight was brought closer, meaning it had less mechanical advantage than the 50-pound weight because that distance was less than 5 times, meaning it was less than 50 pounds pulling downwards. So I've talked about using mechanical advantage with the 10-pound weights in the end. But what is mechanical advantage? So mechanical advantage is using physical objects like this lever here to amplify and maximize the amount of input force put into a system. So as you can see here, using this lever, because this side of the arm is so much longer than the side with the 50-pound weights, it's much easier for me to lift it. This is because of something called torque. Now, torque is a measurement of how much you can rotate from a central point. So like the fulcrum of this lever, how much force you can rotate using that. So on this side, I have about a 1 foot distance between our fulcrum and where the weights are. And it's a 50-pound weight. So that means I have 50 foot-pounds of torque. But on this side, when I had the 10-pound weights, they were about 5 feet out from the fulcrum. So when you multiply those two numbers together, the 10 pounds and the 5 feet, that makes, again, 50 foot-pounds of torque, making those two forces equal. So that means that lever arm wouldn't move at all. But when I moved the 10 pounds out just a bit further on the arm started to move down like that. That's because I added just a little bit of distance to the side. I added like a half a foot. So that would make our torque 5.5 times 10, making 55 foot-pounds of torque. So this side with the 10-pound weights has now more force than this side. But when I brought it in, I would have only about 45 pounds of torque, foot-pounds of torque, and this side would still have the 50, so it would then rotate up like this. So how can all of this stuff be useful? Well, imagine you had to lift up something super heavy like a car. Now you wouldn't be able to lift it up by yourself in one large movement. But say with like a car jack, you can pump the lever of the car jack multiple times to raise up the car. And that's exactly like the system here. You're inputting a little bit of force for a greater distance for the same amount of output as if you just lifted up the car in the first place. So using something like this makes it much easier to lift up heavy objects for the trade-off of you have to put in a smaller amount of force for longer, which is much more manageable than lifting up, say, like 500 pounds once. You can lift up 50 pounds 10 times. Now, something I didn't tell you guys from the start is this lever system I set up is actually a trebuchet. Now, what a trebuchet does is it's an old catapulting device used to launch small objects far distances. Now it still works in the same way as the 50-pound weight and the long arm having different mechanical advantages, but because the tennis ball I've loaded in weighs so much less, then the mechanical advantage is much greater on the 50-pound weight side. Also, just like in the last video, because the 50-pound weight is so much higher than the tennis ball, it has an enormous amount of potential energy. And so when I pull this hook pin right here, it's going to release all of that energy, swing the arm around, bring the tennis ball with it, and launch it that way. So, in 3, 2, 1. There we go. Now that we've seen it launch, let's see it launch again in slow-mo and see exactly how everything's working. 3, 2, 1.
As mentioned before, the 50-pound weight has more mechanical advantage than the long lever arm side. Because of this, the long lever arm is quickly swung around, dragging the tennis ball with it by the ropes. At the top of the swing, one of the ropes releases, allowing the ball to fly out. Thank you for watching, and see you next week.